So we've looked a lot at equations with polynomials, mostly when they're equal to 0, but if it's not equal to 0, we could put everything on one side and make it equal to 0, right? But what about in the inequality case? Because we can imagine situations where maybe this would come up. Maybe, for example, we have a function that's x squared plus 5x plus 4, and it's all under a square root. And we need to know the domain of this problem, right? So maybe in that case, we would need to know what the when is x squared plus 5x plus 4 greater than or equal to 0. Okay. So we can start it by doing it how we would do it when it's normally equal to 0, but it's not going to be as straightforward as the linear case. It's going to be kind of more like the absolute value case, but even then a little bit different. So let's start by factoring like we would if it was equal to 0. Okay. So we want to consider what's happening here. We're looking for the product of two numbers where it's greater than 0. So in other words, it's positive, right? So we're looking for, okay, when is the product of these two numbers going to be positive? That's going to be true when they're both positive or they're both negative. Okay. It's not going to be true if one is positive and one is negative and the other is or vice versa. One is negative and the other one's positive, right? So we could think of it in terms of cases. Okay. So case 1, x plus 4 is greater than 0 and, or we could say greater than or equal to 0, and x plus 1 is greater than or equal to 0. This would mean that the product is greater than or equal to 0. And this would be if x is greater than or equal to negative 4 and x is greater than or equal to negative 1. Okay. So the only time this is true is if x is greater than or equal to negative 1, right? This is kind of like the overlap part, right? Is the x is greater than or equal to negative 1. So we'd say, so x is greater than or equal to negative 1. Okay. If it's greater than negative 1, then it's greater than negative 4, but not vice versa. And then case 2, x plus 4 is less than or equal to 0, and x plus 1 is less than or equal to 0. Okay. So x is less than or equal to negative 4, and x is less than or equal to negative 1. So again, just vice versa this time, it's x is less than or equal to negative 4 overall. Okay. So our answer would be that this inequality appears true when x is greater than or equal to negative 1 or less than or equal to negative 4. So we would have negative infinity to negative 4 included, union negative 1 to infinity. Okay, so maybe we say x is in that. And that would be our answer. Now, this is, it's usually not the preferred way of thinking about it, the cases. We can use, this is really what's happening. So I like to break it down like this first. But a better way of organizing it is using what's called a sign chart. Okay. So let's use a different example and we can go through that. Let's say we have x squared minus x minus 6 is, let's say, less than 0. And if it's not less than 0, like maybe you have something like this, right? Less than 6. Then again, just make it equal to, just make one side 0. Just like we were doing with the equations, we want one of the sides to be 0 here because it's going to make the problems a lot simpler. So either way, you should end up with x squared minus x minus 6 is less than 0. So just make sure one of the sides is equal to 0 for simplicity's sake. So the preferred way of doing this is using what's called a sign chart. And we'll use these a lot when we get to the calculus material. So it's important to get used to them now. So the sign chart basically takes all of the zeros. So on the sign chart, you want to put all of the zeros and all of the bad numbers, meaning numbers that are problematic in the domain. Here we don't have any. One of the nice features of polynomials is that they have a domain of all real numbers. It'll be more relevant when we look at rational functions. Okay. So with the zeros here, we just factor, and oops, sorry. Maybe we set it equal to 0 if we want to be more proper, and then solve for 0. So we get x minus 3, x plus 2 equals 0. So x equals 3, x equals minus 2. And we put those on the sign chart here. And the idea here is that if we think about the graph, if you think about this as the x-axis, and we're looking for the places where this is less than 0. So we're looking for the places where it's below the x-axis. Okay, it can only cross from negative to positive or vice versa at the zeros, right? It has to go through the zeros in order to move from negative to positive or vice versa. Unless there's an issue with the domain, in which case it might jump all over the place. So that's why we put the bad numbers on there as well. But on a continuous function like polynomials, where it's just one continuous line, to go from negative to positive, it has to cross the x-axis, right? And the zeros are the places where it crosses the x-axis, so therefore these are the only places where it can go from negative to positive. So what we do is we say, okay, well, we're looking at 3 regions then, right? We're looking at this region, and this region, and we want to say, okay, is it positive or is it negative in each of these regions? And we only need to look at one number in each region. We need to test one number in each region, because if it's positive at one number, it's positive at all of those numbers, because it can only move at the zeros. Okay. So we take 3 test points here, and one in each region. So maybe we look at 0. F of 0 equals 0 minus 6 equals negative 6. You don't even really need to know what the actual value is. You just need to know if it's negative or positive. So here it's negative. So we put a negative sign to indicate that. And then maybe we do 4, because that's in the 3rd region here. So f of 4 is 4 squared minus 4 minus 6. So that's definitely going to be positive. 16 minus 10 is 6. Again, you don't even need the value. And then maybe we do negative 4. Okay, negative 4 squared minus negative 4 minus 6. So this is 16 plus 4 minus 6. Definitely going to be positive. Okay. So the only place where this is negative is between negative 2 and 3. Okay. So then our answer here, we're looking for the places where it's negative. So our answers is from negative 2 to 3. Okay, x at negative 2 to 3. If you prefer, you could write negative 2 is less than x is less than 3. Okay, so you can use the sign chart method. You could just break it up into cases. I think the sign chart method is a little better to get used to, because like I said, we'll use it in a lot of things later. Which you could break those down into cases too. You just might have a lot more cases. This is just kind of a nice way of organizing it and making it kind of succinct. Especially when we get into things with domain issues and you have a lot more places where you can go from negative to positive.